To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapters, we discussed several things regarding the electrolysis process. We discussed how does the electrolysis is going to occur within a certain substance. So we discussed over there that the electrolysis is going to happen when you provide electricity to a certain electrolyte. So electrolyte is a substance that can pass electricity. However, the substance is a liquid, or else it can be a solution. So we discussed that it can be a fused solution or else a aqueous solution. A fused solution is a solution where we get the substance and we're going to heat it till it's going to turn into a liquid. So such a substance is a fused substance, right? If not, we can take this particular substance. We'll imagine that it is sodium chloride, which is common salt. So you can add that substance into water and make into a solution. So such a solution is referred as an aqueous solution. So both of these substances is going to conduct electricity, but however it should be an ionic compound, right? And we discussed several things regarding to the ionic compounds in the previous chapters. So I hope that you got a good knowledge about those things, about the ionic compounds and the electrolytes and the non-electrolytes and the process of electrolysis. So here now we are going to study about another special kind of an activity, right? This is also regarding the process of electrolysis. Here we are using a different kind of an electrolyte. Now in the earlier case we took like copper sulfate solution, right? And by using the copper sulfate solution, we observed what are the changes that is going to occur when you provide electricity to the copper sulfate solution. Now within this experiment, we'll be using acidified water or acidulated water in carrying out the process of electrolysis, right? So to do this experiment, my dear children, we'll be needing these materials. So let's see what are the materials that we need. So first of all, you'll be needing acidulated water. Acidulated water, then a dry cell, then carbon rods. These carbon rods are made, you know that graphite is made by carbon. So actually as carbon rods we are using graphite rods, okay, graphite rods. Then we'll be needing a water trough or else a water basin, right? Then wires, connecting wires, and to collect the gases which is going to emit, okay, to collect the gases which is going to emit from the system, will be needing two boiling tubes or else measuring cylinders, okay. So I'll mention boiling tubes. Sometimes you can also use gas jars. So I'll mention gas jar as well. Gas jar, right? Actually we'll be needing two gas jars. So within this activity, my dear children, two kinds of gases are going to emit. So therefore you'll be needing two gas jars or two boiling tube in order to collect these gases, okay. So these are the materials that you need, my dear children. What are the materials? Acidulated water or several dry cells. So in order to provide enough current, you'll be needing dry cells. Then carbon rods, you know that the carbon is, here graphite is made up with carbon. So carbon rods means graphite rods. Then a water basin or else a water trough. Then you'll be needing wires. To collect the gases, you'll be needing two boiling tubes or else two gas jars, okay. So these are the materials you need. These are the materials that you need. So we'll head on to see the method. So method is very simple, my dear children. You are given with a figure, right? Like this, you are given with a figure. So what you have to do is you have to take the water basin and you have to fix the two gas jars or the boiling tubes according to the figure, and you have to insert the two electrodes, carbon electrodes, and first of all seal it very well so that water is not going to leak. Okay, over here you have to seal it very well, otherwise water is going to leak. No, so if the water is leaking, we won't be able to carry out the experiment properly. So what you have to do is you have to connect the two electrodes to the water basin according to the given figure, and you need to make sure that these things this one or this system is tightly being water sealed. Okay, so after that what you have to do, you have to place the two boiling tubes or two gas jars like this. Then my dear children, you have to provide electricity to the two electrodes. So here the specialty is that remember to fix the two electrodes onto the basin, right? And you have to seal it very well, otherwise the water will leak. Okay, then we are going to keep the inverted gas jars like this on the system. So by that way we can collect the two gases which is going to emit from the system. Okay, so we'll write down the method. It's really simple. What you need to do is prepare the system according to the given figure. Make sure to seal the electrodes very well to the basin. Then what you have to do, add acidulated water and carry out the electrolysis. Collect the gases which emits and test with a glowing splinter. Right. So once again, let's see what is the method. First of all, prepare the system according to the figure. So this is the figure. According to this figure, you have to prepare the system, my dear children. Make sure to seal the electrodes very well to the basin. So make sure to seal the two electrodes to the basin. Okay, you can use wax or clay or any other substance to seal it. So add acidulated water and carry out the electrolysis. Collect the gases which emits and test with a glowing splinter. Right? So we have to collect the two gases which is going to emit, and we need to test with a glowing splinter. Okay, so this is how to carry out the experiment. Now in here, my dear children, more amount of hydrogen gas, actually the two gases which are getting emitted is given in the diagram. At the negative terminal, hydrogen gas is going to emit, and at the positive terminal, oxygen gas is going to emit. Here the special observation is that when you check the two volumes of gases which is going to collect for the two basins, or for the two gas jars, is somewhat different. Actually not somewhat, there is a huge difference. More hydrogen gas is getting collected compared to oxygen. Okay, more amount of hydrogen gas is getting collected compared to oxygen. So my dear children, we have to carry out the experiment for a longer time period in order to collect like several oxygen. Okay, that several means like more oxygen, so that we can test it with a splinter. Okay, so we have to carry out the experiment for a longer time period in order to collect enough oxygen gas for the container. So my dear children, here I'll be using the test or the experiment carried out for the hydrogen gas. And in the earlier lessons, and when we are doing lessons in the grade 8 also, I think you have got a knowledge about how to identify oxygen gas, right? And even we did several experiments to identify oxygen gas. So we inserted a splinter to a container of oxygen gas, and when providing a flame or else a light flame, what will happen? The flame will reappear once more, or else a light flame will give out a more stronger flame, right? So that's how the oxygen is going to work out with a flame, right? Flame means with a splinter. So if you want, you can insert a lighted, and you have to put off the flame, and then you can insert that thing into the system of oxygen. In that case also, once again the flame will reappear, because oxygen is a good supporter of combustion. Okay, but however, my dear children, within this activity it's going to be somewhat difficult to collect oxygen gas. So therefore I'm going to use hydrogen gas, because hydrogen can be easily collected, and it's more amount of hydrogen gas is getting collected without any trouble. Okay, so within this experiment, when I'm going to conduct it, I'm going to use hydrogen gas, and I'm going to show that how hydrogen gas can be identified, right? Without any trouble we can do it, because more amount of hydrogen gas is getting collected. Okay, right then, so this is the way of doing the activity, my dear children. Now let's head on to the laboratory and we'll conduct the activity, and let's see what are our observations and conclusions from the activity. So my dear children, here, as you can see here, this is the setup which I have prepared to investigate the electrolysis process of acidulated water. So this is acidulated water which is on the trough. These are the two gas jars or the test tubes. As you can see here, there are two carbon rods. This is our dry cell. So this brown color one indicates the positive terminal. This is the positive terminal. This is the negative terminal over here, which is indicated by blue color. Okay, so this is negative terminal or the negative electrode. Now let's turn on the switch and we'll observe what's going to happen. So as soon as I'm going to turn on the switch, here you can clearly observe gas bubbles are coming from both the test tubes over here. However, we can observe the gas bubbles are like large amount of gas bubbles are coming from the negative terminal. See, from the blue color, negative terminal, large amount of gas bubbles are coming out. From the positive terminal, once again gas bubbles are coming, but not that much as the other terminal. So we have to keep this system for a while, and we have to collect the two gases that's going to emit from these two terminals. Okay, So as you can see here, gas balls are now rapidly coming out from the negative terminal. So we have to collect these gases, right, my dear children? We have to collect these gases. So we have to keep the setup for a while. So let's collect the gases, then we'll observe by adding a splinter what's going to happen. So my dear children, so as you can see here, now I have moved the two test tubes in order to observe the volume of gas which is collected. As you can see here now, it's very obvious and very clear to us that more gas volume is being collected onto the negative terminal. See, and the gas volume which is collected at the positive terminal is somewhat lesser than it. Okay, more gas volume has been collected onto the negative terminal. As you can see here, it's very clear to us. Observe. However, the gas volume created at the positive terminal is somewhat less. So we have to collect. In order to observe, in order to get a good observation, we have to collect gases up to like certain kind of a height. So it's still in the, like initial stage. So we have to keep the system somewhat for a longer time to collect certain amount of gas. So once again, let's keep the system for a while and let's observe. So my dear children, now a certain volume of gases, right, has been collected to both the test tube right now. This is the positive terminal. There is a small bit of a acidified water column left within the test tube of the positive terminal. So this is the positive terminal. However, a good gas amount or good collection of gas can be observed within the negative terminal over here. Now what I'm going to do is I'm going to safely turn off the switch. We have to turn off the switch first of all, right? So now I'm going to safely dip my hand within the solution. Going to keep the finger beneath the right now. This is the gas which is at the negative terminal. So let's insert a glowing splinter into this gas and we'll observe what's going to occur or what is our observation from the splinter experiment. Okay, so we have to insert a glowing splinter and we'll observe what's going to happen. So my dear children, now we are going to insert a splinter, but however, rather than inserting a splinter into this gaseous container, I'm going to insert this candle, a lighted candle. So we'll observe what's going to happen. Okay, so I'm going to insert this gas container into the lighted candle over here, right? So it's very clear to us that. So my dear children, it's quite obvious to us that it's going to emit a good pop sound, and as you can see, the candle flame is also going to put off, right? So what is the reason for that? Because this container, this gaseous container, right, it contained hydrogen gas. Hydrogen is a combustible gas. So upon inserting this combustible gas into a splinter or else to a flame, what will happen? The hydrogen gas is going to light up, and because of that process, it's going to combust. So because of that process, my dear children, right, what happens? It's going to emit a pop sound, and also the flame is also and also due to that thrust, the flame is also going to put off, right? So it's quite obvious to us that the negative terminal, the black colored negative terminal, right, the blue color wire, black color crocodile clip, the negative terminal, this one, it contained hydrogen gas. So my dear children, this is the container that is in the positive terminal. So within the positive terminal, the gas which is getting collected is oxygen. However, here now very less amount of oxygen is there. So you know that it's quite easy to observe oxygen gas. So what I'm going to do here is I'm not going to show that oxygen is going to be produced by using the splinter case or by using the splinter experiment. Actually, it is somewhat difficult to carry out the experiment to show that there is oxygen, because as soon as I'm going to release my finger, right, your oxygen gas is going to come out. So if you want to get a clear view or clear observation, then we have to use somewhat larger container. So therefore, but however, my dear children, here the gas which is getting collected is the oxygen gas. Hydrogen is quite simple to collect. It's because hydrogen is a very lightweight gas. So like oxygen, it's not going to escape from a certain container, as it is always going upward, as it has very light weight. Okay. So my dear children, and there is another case. The other one is that now we kept this system for a very long time period. Now, if I'm going to keep the system for a shorter time period, I won't be able to collect this much of oxygen. The oxygen gas which is coming out from this electrolysis process of acidulated water is also very less. I told you that in the earlier case also, right? So I'm not going to do the experiment regarding the oxygen gas, right? But however, you could clearly observe that there was hydrogen gas within the negative terminal. Right then, so let's head on to the classroom once again and we'll write down our observations and conclusions from the activity. Right, my dear children, so we conducted the activity, okay? And from the activity, we could clearly observe the presence of hydrogen gas and the presence of oxygen gas. And you could also see that gas bubbles are going to evolve from the two terminals, right? It's very obvious when you provide electricity only, right? Only when you are providing electricity to the system, right? The gas bubbles are going to emit. So here within the electrolysis process of acidulated water, two gases are going to emit. At the negative terminal, hydrogen gas is getting collected. At the positive terminal, oxygen gas is getting collected. When you compare the two volumes, more amount of hydrogen gas is getting produced compared to the volume of oxygen. Okay, more amount of or more volume of hydrogen gas is getting produced at the negative terminal rather than the oxygen gas in the positive terminal. Okay, right. So these are our observations. Okay, so we'll write down our observations, my dear children. Observations are quite simple. Number one, gas bubbles emits from positive terminal. Then number two, or else we can directly write like this: gas bubbles emit from positive and negative terminal. So gas bubbles emit from positive and negative terminal. Number two, more amount of or more volume of gas is collected more volume of gas is collected at the negative terminal. At the negative terminal. So more volume of gas is collected at the negative terminal. These are our observations, my dear children. Now, what do you mean by an observation? Observation is a certain thing which you can detect in the system. Okay, which you can detect in the system by your sensory organs, especially from eyes or from your ears. From ears we can hear a sound, from eyes we can see whether there is any kind of a change, like change in color, emission of gas, or any other. Okay, sometimes our nose can also be used if there are any other smells are going to come during the chemical process. So in that case we can use our nose as the sensory organ to detect these observations. So my dear children, when you are writing observations, you won't be able to write down as the gas is oxygen, or the gas which is going to emit from the negative terminal is hydrogen. Like that way you can't write, because you can't directly observe whether that gas is oxygen or hydrogen, because both the gases are colorless and odorless, and therefore we won't be able to identify these gases properly. Okay, so in order to show that these gases are hydrogen or oxygen, you have to conduct another experiment. Actually, we did that experiment. We inserted a globe in splinter, right? So by that way only we can conclude whether the gas which is going to emit is hydrogen or oxygen. So within the observations you can't write those things. The gas which is going to emit at the positive terminal is oxygen, and the gas which is going to emit at the negative terminal is hydrogen. Like that way you can't write all the observations. Okay, within the observations we won't be able to observe whether the gas which is going to emit is oxygen or hydrogen. We can only see that several gas bubbles are emitting from the two terminals. That's it. So there is no possible way to say that these gases are oxygen and hydrogen. So we have to collect those things, and we have to once again carry out experiments in order to identify these things. So we'll write down those things at the conclusion part, my dear children. So for the observation, I'm going to write down only these two. That means within the observations, we don't know whether the gas which is going to emit in the system is hydrogen or oxygen or any other. Okay, so when you are writing observations in these cases, if you have been asked to write down an observation, don't write as oxygen gas or hydrogen gas or any other, because you won't be able to observe these things from your naked eye, and the gas which is going to emit is not going to label themselves and go out, right? That kind of a thing is not going to happen. If so, then we can identify, like if the oxygen particles are going like I'm oxygen, then we can identify, there's no problem in it. But however, gases can't do that kind of a stuff, right? So we have to use a different experiment in observing or in identifying these gases. So my dear children, here I have mentioned gas bubbles emit from positive and negative terminals, right? So more volume of gas is collected at the negative terminal. So we don't know what are these gases. So in the conclusion part, I'm going to write down the two types of gases which is going to emit, because over there we conducted another experiment to see whether the gases which are going to emit is oxygen or hydrogen, right? So let's head on to see the conclusion then. So our conclusion: when a glowing splinter is inserted to the gas or the gas jar at negative terminal, okay, it burns out with a pop sound. Therefore, hydrogen gas is collected at the negative terminal. Okay, at the negative terminal, hydrogen gas is collected. How can you say that? Because when we insert a glowing splinter, right, it burns out by giving out a pop sound. Okay, so we can write down the first conclusion. hydrogen gas emits from the negative terminal. Hydrogen gas emits from the negative terminal. How can you say that? Glowing splinter gave a pop sound So that's enough, right? Yes. So glowing splinter gave a pop sound, right? Glowing splinter which we added gave us pop sound. So therefore we can conclude that hydrogen gas emits from the negative terminal. Then number 2, oxygen gas emits from positive terminal. Oxygen gas emits from positive terminal. Here you know that the glowing splinter is going to give out a bright flame, okay? Splinter will give a bright flame. And there is another conclusion. What is the final conclusion? There is another one. So my dear children, you know that water is made up with the two substances, oxygen and hydrogen. So the chemical formula for water is H2O. So oxygen and hydrogen bonds together to create the water molecule. So when you are providing electricity to the water, to the acidulated water, what happens here is oxygen and hydrogen breaks down to form oxygen gas and hydrogen gas. That means a complex molecule has broken down into simpler structures or simpler components. So we can say that during the electrolysis, acidulated water has been converted to simpler compounds, right? Acidulated water converts to simpler compounds during electrolysis. That is our third and the final conclusion, right? So we can write acidulated water converts to simpler to simple. Acidulated water converts to simple substances during electrolysis. Right. So these are our conclusions. Number 1, hydrogen gas is going to emit from the negative terminal because the glowing splinter is going to give out a pop sound. We did that thing, right? So second one, oxygen gas emits from positive terminal. I told you that it's somewhat difficult to collect oxygen gas, right? So however, if you can insert a glowing splinter to a container of oxygen gas, then it will provide a bright flame, because oxygen is a good supporter of combustion. So oxygen gas emits from the positive terminal, because the splinter is going to give out a bright flame. Okay. Then the third one, acidulated water converts to simple substances during electrolysis. So from those two conclusions, we can once again come out to a different conclusion, right? That the water or the acidulated water is going to convert into simpler substances like hydrogen gas and oxygen gas upon the process of electrolysis. So here we can break down water molecule into two different parts or two different simpler parts by the process of electrolysis. Okay. So once again, my dear children, remember these things. At the negative terminal, hydrogen gas is going to emit. At the positive terminal, right, at the positive terminal, oxygen gas is going to emit. And water is breaking down into simpler substances like oxygen gas and hydrogen gas, right? Now let me explain how does this oxygen and the hydrogen gas is going to emit when you provide electricity to the system. Okay, right. So I'll take the slide somewhat up so that I can explain what's going to happen over there. So you know that this is our system. The two electrodes. You provide electricity. This is the positive terminal then. And this is the negative terminal. You know those things, my dear children, because within the dry cell, the shorter terminal is the negative one and the longer terminal is the positive one. Now this is acidulated water. So within acidulated water, why do we need to add acids for the water? Because when you add a few drops of acid to water to make that thing into acidulated water, my dear children, it helps to break bonds between the water molecules. And water molecules will create mobile ions in here. Mobile ions. It means that when you add like substances, acids or bases, water is getting converted into two different ions. Those two ions are one particular hydrogen atom or else a particle is getting separated as hydrogen plus. It means the electrons which contained within hydrogen is going to be removed, or it is being removed, and that removed electron is obtained by the remaining part, which is the OH. Because there are two hydrogens, one hydrogen is getting divided as hydrogen plus, the other remaining part is getting into minus. So that is the part that has that electron which is obtained from the hydrogen which is over here. So when you are providing several acid drops, or when you drop several acids drops to a container of water, water will break down into hydrogen plus ions, and this is called as hydroxide because it contains hydrogen and oxygen. Hydroxide. So hydroxide. So it breaks down into two ions, hydrogen plus and OH minus, which is referred as hydroxide. Okay. Hydrogen and hydroxides. So this is hydrogen plus, This is hydroxide, which is minus. Now you know that when you are providing electricity to the circuit, what will happen? All the negative ones will come to the positive terminal, which is over here. So to the positive terminal, OH minus ions will come, because as they are having opposite charges, right? Because they are having opposite charges, OH minus ions will get attracted towards the positive electrode, and the hydrogen plus ions will get attracted towards the negative electrode. Now my dear children, what will happen? At the negative electrode, hydrogen will receive more electrons, because at the negative terminal, you know that there are plenty of electrons. So at the negative terminal, hydrogen will receive once again electrons. This hydrogen plus then will convert into hydrogen gas, and it will get emitted from the system. Then what happens to this thing? Actually, as there are oxygen in here, this will break down in forming oxygen gas. So this is how oxygen and hydrogen are getting created within the system, right? Within the system of acidulated water. And however, here you need to provide the electricity for the breaking down process. Okay, so this is how the breaking down of ions is going to occur within water. And my dear children, the emission of hydrogen and oxygen is going to occur. It happens mainly because of the provision of a certain electric current to the electrolyte. If there is no electric current, then we won't be able to observe these gases. So my dear children, we can come into another conclusion that the electrical energy which is getting provided to the system is getting converted into chemical energy. As gases are getting formed, we can say that the electrical energy which we are going to provide into the system is going to convert into chemical energy, as there are different chemical substances is going to create within the system. So during the electrolysis process, we provide electricity to create out a chemical reaction. So in the chemical reaction, we know that different chemical substances are going to create. So here the electricity is getting converted to chemical energy, right? So this is how the process of electrolysis is going to occur within the acidulated water. So up to now, you remember these things, my dear children. When you go further with your grades, like in grade 10 and 11, mostly in grade 11, you'll be identifying the full process of electrolysis in detail, like how the way it is going to occur, right? So you'll be identifying all of these things very well, okay, when you go to grade 11. So up to now, I have given you just a simple bit of a brief, that's it, okay, right then. So this is the way of creating hydrogen and oxygen gas respectively at the negative and positive terminals, okay, right. So my dear children, now let's head on to see what are the other contents. So here you are given with the explanation once more. In this activity, it can be observed that gas bubbles evolve at the electrodes. The gases evolved get collected in the test tubes. So here we use gas jars, right, or boiling tubes, okay. The volume of gas collected at the negative electrode is approximately twice the volume of the gas collected at the positive electrode. So like I said, at the negative electrode means at the negative terminal. So at the negative terminal, approximately twice the volume of gas is collected when you compared it with the positive terminal. Like I said, my dear children, at the negative terminal, you know that hydrogen gas is going to evolve, right? Hydrogen gas is the one which can be observed at the negative terminal. So at the negative terminal, more gas is getting liberated when you compare it with the oxygen, right? More amount of gas is going to liberate from the negative terminal. So at the negative terminal, we can say that the gas which is getting collected is somewhat approximately twice the volume when you compare it with the positive terminal. Okay, approximately and not exactly. However, we can say that gas collected at the negative terminal is way more greater than the gas which is collected at the positive terminal. Okay, right. So the volume of gas collected at the negative electrode is approximately twice the volume of gas collected at the positive terminal of the electrode. It can be examined that hydrogen gas evolves at the negative electrode and oxygen gas evolves at the positive electrode. So like I said, my dear children, by inserting a globin splinter, we have concluded that thing also. Even though I haven't used the oxygen experiment, I have provided you the experiment for the hydrogen, or how to prove that hydrogen is going to emit within the negative terminal. I have provided you that thing, right? So we can come into a conclusion that finally, what is the conclusion? Hydrogen gas evolves at the negative terminal and the oxygen is going to evolve at the positive terminal. Okay, so these are our observations from the experiment. So we discussed these things earlier also. Then my dear children, the gas evolved at the positive electrode is collected and tested with a glowing splinter. The splinter reignites. This verifies that the gas evolved at the positive electrode is oxygen. So like I said, when you take the gas which is collected at the positive terminal and when you insert a glowing splinter into it, right, at the positive terminal, you know that oxygen gas is going to emit. However, we need to prove it. So to prove, we can insert a glowing splinter. So when the glowing splinter is going to receive more amount of oxygen contained within the container, the flame will reappear, or else a bright flame could be observed, right? So from that we can come into a conclusion that the oxygen is there. Then the next one, if the gas evolved at the negative electrode is separated and lighted splinter is put into it, the gas burns with a squeaky pop sound. Okay, this confirms that gas evolved, right? Gas evolved at the negative electrode is hydrogen. So it is giving out a pop sound. We carried out that experiment. You could clearly observe that the splinter is giving out a pop sound, and also the flame of the splinter is going to put off, right? So it confirms that negative terminal contains hydrogen gas. Thus, during the electrolysis, water is split into more simpler substances, hydrogen gas and oxygen gas. So it is very obvious to us that here the water, or the acidulated water, is getting separated into simpler substances like hydrogen gas and oxygen gas. So this is our final conclusion from this activity. During each and every process of electrolysis, the electrolyte is getting separated into more simpler substances. Okay, it's valid for all the electrolytes, not only for the acidulated water. It is valid for each and every electrolyte. So each and every electrolyte is getting separated into simpler substances when you provide electricity. Okay, that's how the electrolysis process is going to work. So my dear children, this is the process of acidulated water, the electrolysis of acidulated water. Right, my dear children. So let's head on to observe what are the other contents. So now within the next subtopic, so you are given with the subtopic here. So within this subtopic, we'll be discussing about the applications of electrolysis. So you are given with the point, electrolysis is frequently used in various industries. So we use the process of electrolysis in various industries, my dear children. Okay, one industry, actually you already know about one industry. So that industry is electroplating. In the electroplating industry, we use the process of electrolysis. Actually, electroplating is also electrolysis. Here we are going to plate a certain metal on another metallic object by using the process of electrolysis. As a different metal is getting plated on another different object, the process is referred as the electroplating. Okay, it's referred as the electroplating. So the process of electroplating is also going to occur because of the electrolysis. Okay, right. So electroplating is one industry. So we use electroplating in order to make different kinds of substances or materials like necklaces, statues, medals, trophies, and so on. So it's, you know that it's very expensive to buy 100% gold stuff. So in that case, my dear children, we can use the process of electroplating, right? And we can plate a certain different kind of a material by using gold. Different kind of a metallic material by using gold. So it would be somewhat cheaper rather than buying 100% pure gold substances. Okay. So most of the times these electroplating process is being used by jewelry industry and in making like trophies, statues and medals and so on, the like those substances, electroplating process is being used. Okay, so electroplating is also a good example, right, for the process of electrolysis. It's an industrial application of electrolysis. Okay, the difference here is that we provide electricity in here to plate a certain metal on a certain different kind of a metallic object. That is why it is referred as the electroplating. Okay, right. So we can write down the first one in electroplating. In electroplating. Then the next one, in manufacturing chemicals. In manufacturing chemicals, chemicals like caustic soda. The chemical name for caustic soda is sodium hydroxide. A good base. Okay, right, sodium hydroxide. Chemical formula is NaOH. This is the chemical formula, NaOH. So in manufacturing chemicals like caustic soda, we use the process of electrolysis. Okay, in manufacturing caustic soda or sodium hydroxide, we use electrolysis. So the chemical formula for sodium hydroxide is NaOH, a good base. Okay, then next one, number 3, in extraction of metals. In extraction of metals like aluminium, and sodium. My dear children, aluminium and sodium, aluminium, sodium, magnesium, calcium, right, and also zinc, these metals are very reactive. Actually, if you take like metals like sodium, potassium, calcium, those metals are way more reactive. Those are the most reactive metals, right? Those are the most reactive metals that we can observe. Okay, there are some certain other metals which are even more reactive than these things, but however, in normal conditions, I mean, like when you go in our normal conditions, like up to now in our O-level syllabus, now you are still studying O-level, no? So in grade 9, right, and 10 and 11, within these grades, right, the most reactive metals that we come across is potassium, sodium and calcium. And also if we can take magnesium as well, but however magnesium is somewhat lesser reactive than those substances, right? So within our O-level syllabus, like in grade 9, 10 and 11, right, potassium, sodium and calcium are the most reactive substances up to our knowledge. When you go further with your studies, you will get to know that there are even more reactive metals within our world. Okay, up to now this knowledge is enough. So sodium, potassium, calcium, right, sodium, potassium, calcium, these substances are very reactive. I mean, like their reactivity is so much high. Sodium has a very high reactivity, so that we won't be able to keep sodium in our normal environment. If you keep sodium in normal environment, it will degrade way more faster, it will corrode very faster. Okay, and the other thing is that if a drop of water is going to come on contact with sodium, then huge explosions will also occur, right? Drop of water is enough to make it explode. It's because that, my dear children, the reactivity. So because of this higher reactivity, sodium is never going to exist in our environment as a native element. I mean, like sodium metal, we won't be able to observe a sodium metal, because the metal is now creating different other compounds with the substances in our environment. Okay, it's because of the reactivity of sodium. It's because of the reactivity of sodium. So because of the higher reactivity of sodium, we won't be able to get sodium metal in the from the environment. So in that case, we have to extract the sodium metal, or we have to remove out the sodium metal from a compound in the environment. For that process, we use electrolysis. Actually, in grade 11, you will study about extracting sodium metal. Sodium metal, just for now, I'll give you a simple brief. Sodium metal is extracted from a molten solution of sodium chloride or common salt, right? So this is a heavy, or else a heavy, I mean, like that's a heavy process. Okay, so you'll be learning this thing in grade 11 in detail, with the process and the structure which we are going to use in extracting sodium. We won't be able to carry out these things in our normal conditions, because you know that to make out a fused solution, we'll be needing extreme temperature. We need extreme heat energy, right? So we have to make a fused solution of sodium chloride in order to extract sodium from it. Okay, and here also we use the process called electrolysis, right? So by using sodium chloride, we can extract sodium metal by the process of electrolysis. Here fused solution of sodium chloride is used. And the other one is aluminium. Aluminium is also the same, my dear children. We can use aluminium, we can extract aluminium by using the process of electrolysis. Okay, right, because these substances or these metals are more reactive, so these substances are only available in the environment as compounds. Aluminium can be found, but however sodium will not be able to observe, right? Sodium will not be able to observe in our normal environment. Because of that higher reactivity of sodium, even sodium is inserted into kerosene or paraffin wax, right? Kerosene oil, either in kerosene oil or else paraffin wax. We have to insert, if you have sodium at your home. Actually, you won't be able to find out sodium at homes, right? Because it's prohibited, right? So in school laboratory, you might find sodium. So very small pieces are given to, so even for the schools as well, because those things are very terrible and dangerous. So sodium, these pieces of sodium are being inserted into kerosene oil or paraffin wax because of their high reactivity. If you keep this sodium in normal environment, it will corrode very faster and you won't be able to absorb sodium in the next day, right? So therefore, sodium is being inserted into kerosene oil so that they would not come in contact with the external environmental conditions. Okay, right? So sodium is that much powerful. Potassium is even more powerful than that. So actually here we are not going to speak about potassium, okay, within our grade 9 10 syllabuses, grade 9 10 and 11 syllabuses also, right? Potassium is not even being discussed over here, the reactivity of potassium. So potassium is even more destructive than sodium. Okay, so a simple bit of a brief about these metals, my dear children. So these more reactive metals are extracted by the process of electrolysis. Here we use the fused solutions in extracting those metals. So by the process of electrolysis, we can extract metals like aluminium and sodium. Okay, so these are the industrial applications of electrolysis. In electroplating, we use the process of electrolysis. In manufacturing chemicals like caustic soda or sodium hydroxide, we use the process of electrolysis. And for the extraction of metals like aluminium and sodium, we use the process of electrolysis. Okay, right. So let's head on to observe the other contents. Now, my dear children, we are going to carry out another special experiment. So within this experiment, we are going to plate copper on an object. On a certain object, we are going to plate copper, right? So by the looks of it, you know that this is somewhat related to electroplating. Actually, it is. This is the process of electroplating. Okay. So I'm going to show you how the electroplating process is going to be conducted in our laboratories and in sometimes outer environments. Okay. So you might have seen that near certain jewelry shops, there are certain stalls, and within these stalls, smaller stalls, there is like liquid, kind of a liquid substance, and there are several necklaces, right? And a person is going to insert that necklace into that solution and is going to provide electricity. Then he's going to polish and give it to the certain person which the necklace is belongs to. So that in that case, my dear children, right, the person over there is using the process of electrolysis. He actually is going to plate gold on a certain different object over there, the necklace, on the necklace. Okay, so now we are going to investigate how to carry out a process of electroplating. So you are given with an activity, the plating process of plating copper on an object. So to plate copper or in electroplating, you'll be needing these substances. So now let's see what are those substances. So you'll be needing copper sulfate solution, right? Copper sulfate solution. Copper sulfate solution. Then this is a copper plate, my dear children. Copper plate, a copper plate. Then we'll be needing an object. It can be an iron nail or else a spoon or any kind of a different metallic object. Okay, it can be any spoon or iron nail or any other, right? So here an object, we'll mention a metallic object, metal object like spoon or else a nail. Then a beaker, right? A beaker, will be needing dry cells to provide electricity and wires to connect the system. So these are the materials you need, my dear children. What are the materials? Copper sulfate solution, a copper plate, any kind of a metal object like spoon or else a nail or any other. Then a beaker, dry cells and wires. So these are the materials you need. Okay, these are the materials you need, my dear children. So you'll be needing a copper sulfate solution, copper plate, a metallic object like a spoon or else a nail, then a beaker, then dry cells and wires. So now let's head on to observe our method, right? Method of doing the experiment. So once again a figure given. It's very simple. See, you have to insert the copper sulfate solution to the beaker. Then my dear children, what do you have to do? By using the connecting wires, you have to connect the object to the negative terminal of the dry cell. It's very important to connect to the negative terminal, right? It's very important to connect object to the negative terminal, very important. Then to the positive terminal, you need to connect, right? To the positive terminal, you need to connect the copper plate. Okay, to the positive terminal, copper plate, to the negative terminal, the object that we need to plate copper. Okay, right. So when connecting these things, you can use connecting wires. Okay, then you put the copper sulfate solution and you dip these two when you dip these two objects into the solution of copper sulfate, the process of electroplating is going to occur. Okay, so let's write down the method, my dear children. Actually, these methods are very important. So I'll put a star mark and I'll circle it because it's very important to connect in this manner. Otherwise, the process will not occur for sure. Okay. So first of all, so I'll write like this, the important ones at the bottom. So first, what you have to do? For copper sulfate solution to the beaker, right? Pour copper sulfate solution to the beaker. Then, this is important, connect the object, right? Connect the object to the negative terminal. Using wires. And the other important one, connect the copper plate to the positive terminal, right? Connect the copper plate to positive terminal. Connect the copper plate to positive terminal using wires. Then dip the materials in the beaker and observe the changes. right? So this is the method. Pour the copper sulfate solution to the beaker. First of all, to the beaker you have to pour the copper sulfate solution. So this is the beaker and this is the copper sulfate solution, my dear children. As you can see here, this is the copper sulfate solution. Then connect the object to the negative terminal using wires. It's important to connect the object to the negative terminal, okay? See, the negative terminal object using wires. So using wires, we need to connect the object to the negative terminal of dry cells. Then connect the copper plate to positive terminal using wires. So using wires, this is the positive terminal. As you can see here, the copper plate is connected with the positive terminal over there. Then next one, dip the materials in the beaker, right? Dip the materials in the beaker and observe the changes. And then you have to observe the changes after few minutes. So this is the way of doing the activity, my dear children. Now let's head on to the laboratory once more and we'll conduct the activity. And let's see what's going to happen when you are conducting the experiment. So my dear children, within this activity, here also we are investigating about the chemical effect given out by the electric current. But however, what I'm going to do in this time is, I'm going to use that electrolysis process in order to plate copper on the spoon that I have in here, right? So first of all, I have a copper plate with me. I have scratched it by using a sandpaper. Then I have a copper sulfate solution. So if I'm going to plate copper on a certain surface, I have to use a sulfate or else a solution of copper. So here in this time we have used copper sulfate solution. Okay. So this is my positive terminal now. As the positive terminal, I have to use this metal plate which is copper. So I'm going to insert this into the system. Then let's connect it with the positive terminal of the dry cell, the red color one. So my dear children, the other case is that it's important to not to touch with the negative terminal, right? Negative terminal is now my spoon in here. So I'm going to insert. So you can see there are no any other metals which are plated on the spoon. You can see it very clearly, right? There's nothing in here. So I'm going to insert it and make sure that they do not come in contact with each other. Then we'll connect it with the negative terminal of the dry cell here. Right. So we have to wait for a while. Now if you check the spoon in here, you can see that there are gas bubbles which is getting created. So we'll wait for somewhat time and let's see what's going to happen. Right, my dear children, now let's see what has happened here. So as you can see here, it's very clear to us that there is a copper color, like brownish color substance on the spoon. See? So there is a brownish color substance, right? I can wipe it off by using, right, a tissue paper. I'm going to wipe it off. See? So this substance is copper, right? So copper is getting plated on the spoon. Once again, I'm going now. Let's remove the stain like this. And once again, I'm going to show it to you. So here you can observe it very clearly. See? So let's wipe it off. So I have wiped it off. So let's insert it once again. Right, so I'm going to take it off. And you can clearly observe once again, there is copper around the spoon. See? Right. So I can remove it by using this. See? So there is a clear stain. You can see it very clearly. There are two different colors. See? Right. So here we can finally conclude that within this system, when I'm going to provide electricity for the copper sulfate solution, for the copper plate over here at the positive terminal, on the negative terminal we can plate copper, right? So always the object which the metal needed to be plated, it should be in the negative terminal, while as the positive terminal you have to use a metal rod or else a metal piece that we are going to plate should be on the positive terminal. Okay, so if you are plating gold, then we have to take a piece of gold as the positive terminal and the negative terminal whatever a necklace or else a jewelry, right? So this is how the plating process is being conducted even in the industrial level. So it's really simple, right? So this method is referred as electroplating. Here also we provide electricity in order to get or in order to uh, give out a chemical effect, right? So let's head over to the classroom once again and write down our observations and conclusions from the activity. Right, my dear children. So we conducted the activity and you could clearly observe that the copper is going to plate on the metallic object over there, right? So on the object, copper has been plated, right? So you have to carry on this experiment for about few minutes in order to observe a good layer of copper within the object. So that was our first observation. And there is another observation. If you continue this for a longer time period, we could clearly observe that the copper plate is going to dissolve within the solution, right? Copper plate is going to dissolve within the solution. That means the copper which is at the positive terminal is going to dissolve and it is going to deposit on the negative terminal. So here it's not that much simple. Actually a heavy chemical reaction is going to occur over there, right? Okay, heavy chemical reaction is going to occur over there. So you'll be studying about those things when you go with the further grades, my dear children. For simple, we can say that the positive terminal contains copper plate. So that copper plate is going to dissolve within the solution and get plated on the negative terminal which has the object. In simple, that's the explanation. So we can write down the observations, my dear children. Number one, copper metal, right? Here, my dear children, we can directly say that it is copper metal. Why is that? Because it is having a reddish brown color substance. The only reddish brown color substance present within that system is copper. So here we can directly say that copper is going to plate on the object because it has a unique nature or unique color. So that observation is quite obvious. In that case, we can write it as copper. There is no problem. Right? Copper metal, brownish red. So copper metal brownish red color is plated on the object. This is the first observation, right? Copper metal, which has a brownish red color nature, is plated on the object. Then the second one would be copper plate will dissolve in the system or in the solution. So copper plate will dissolve in the solution and copper metal is plated on the object. So these are our observations. So this is the process of electroplating, my dear children. Here we dissolve the copper plate which is at the positive terminal and we plate that copper on the negative terminal, right? So this is the process of electroplating. So here we use the process of electrolysis in order to provide electricity and in order to carry out the electroplating process. So electroplating is also a sub-unit or else a sub-category in electrolysis. Okay, electroplating is also a subcategory in electrolysis. Right then, so let's head on to observe the other contents. So in the activity you can observe that the copper plate gradually dissolves and copper is deposited on the iron nail. So like I said, even we wrote down these observations. First observation is copper plate is going to gradually dissolve and the second one is copper is deposited on the iron nail or copper is plated on the iron nail. The plating of a certain metal on another surface using electricity is referred to as electroplating. So by using electricity we are going to plate another metal on a certain different kind of a metallic surface, right? On a metallic surface we have to plate or we are going to plate another different kind of a metal by using electricity and by the process of electrolysis. So this is referred as the electroplating. For electroplating, metal that needs to be plated should be used as the positive electrode. Electroplating process, metal that need to be plated should be used as the positive electrode. And the object that is plated should be used as the negative electrode. So, object which need to be plated should be used as the negative electrode. So object that is plated should be used as the negative electrode. Metal that needs to be plated on the particular object should be used as the positive electrode. Metal should be at the positive, object should be at the negative. Next one. Further, the electrolyte used needs to be a solution of a salt of the metal that should be plated. Then the next one is the electrolyte used be a solution of salt of the metal that should be plated. That means if you need to plate copper, then you have to take a salt of copper like copper sulfate solution. If you need to plate gold, then you have to take gold sulfate or gold chloride or any kind of an electrolyte that has gold. If you need to plate silver, then you need to apply silver sulfate, silver chloride, silver cyanide, like that way. Different kind of an electrolyte. We have to use one electrolyte, but however, there are different electrolytes present that has the same metal. Okay, so however, the metal which need to be plated, right? If you are plating silver, then you have to use silver chloride or silver sulfate or any other kind of an electrolyte that has the silver. Okay, so this is how, these are the special key points. Okay, this is These are the special key points in making or in doing electroplating process, my dear children. Okay, right. So once more, electroplating is the process of plating a certain different metal on another metallic object, okay, by using or by providing electricity. Then when doing the process of electroplating, it's important to, right, when doing the process of electroplating, it's important to use the object as the negative terminal, use the plate as the positive terminal, and the metal which need to be plated on the particular object, okay, right. We have to find or we have to use an electrolyte that has the same particular metal, okay. So those are the three main key points that we need to think or that we need to consider when you are doing an electroplating process. Right then. So my dear children, you are given with an assignment. Electroplating silver on an iron plate. Electroplating gold on a copper ring. Draw figures suitable apparatus as in the figure above. For number 1 and 2 instances, state in the positive electrode, negative electrode and the electrolyte in each case. Right. So I'm going to draw out these things. This is number 1. In number 1, it is given that silver on an iron plate. So I'll use the iron plate a different color. Let's take okay, this one. This is the iron plate. Okay, this is the silver. Okay, I'll take this one as the silver plate as it has a unique silver color nature. Okay, so this is the silver plate, right? Then the iron plate. So I'll use brown color, right? I'll use a different color. So this is my iron plate. Iron plate. Now you need to plate, right? You need to plate silver on the iron plate, my dear children. So here we need to use an electrolyte of silver, like silver chloride, right? Silver chloride can be used, or silver cyanide, right? So electrolyte of silver. Then we need to connect the terminals properly. This is the silver plate. So silver plate should be at the positive terminal. It should be at the positive terminal. Right. This is the iron plate. Iron plate should be at the negative terminal. So this is negative and this is positive. So these key points are very important. Now this is the silver plate. And this one is the iron plate. Right. So this is the diagram in plating silver on iron plate. So this is silver plate used as the positive terminal. This is the electrolyte of silver, and iron plate used as the negative terminal. So this is number 1. Then we'll draw second one, my dear children. Number 2. right? In number 2, electroplating gold on a copper ring. On a copper ring, you have to electroplate gold. Okay. Right. So this is the copper ring. Right, the copper ring. Copper ring, my dear children. Now, the gold plate. You have to use a gold plate. The gold plate. Then the connecting wires. This is the gold plate and it should be the positive terminal, the longer one. This is the copper ring and it should be the negative terminal. And the electrolyte should be also from gold, right? Also from gold, like gold chloride or gold sulfate or like that kind of a salt, right? That kind of a salt should be the one which is used as the solution, or that is the one should be used as the electrolyte, solution of salt, right? Solution of gold salt, right? Then I have to use the solution. So this is the solution. Electrolyte of gold. So this is the negative terminal. This is the positive terminal. Positive terminal is connected with the gold plate. And the negative terminal is connected with the copper ring. Right. So these are the figures during the processes of electroplating of silver on a iron plate and gold on a copper ring. So speciality here is that remember always positive terminal should be the metal that we need to plate, right? That is the metal which we need to which we used in plating process, and the negative terminal is the object which need to be plated. Negative terminal, object which need to be plated. Positive terminal, the particular metal that we are going to plate on the object. Okay, and the electrolyte also should be the same as the metallic object, or as the metal plate which we use for the positive terminal. It should contain the same element, right? Silver, electrolyte of silver, silver plate, positive terminal. Okay, so these are the two figures, right? First one, electroplating silver on an iron plate. This is the iron plate and the silver plate, dry cells, electrolyte of silver, first figure. Electroplating gold on a copper ring, negative terminal, positive terminal, gold plate, and the electrolyte of gold, right? So this is the process of electroplating, my dear children. In electroplating also we use the process of electrolysis. Okay, right then. So with that part I'm going to finish up the chapter, my dear children. Within next chapter we'll be discussing further things related to the electroplating process. So I hope that you will stay with me till the end of the lesson, and we'll discuss several other things related to the electroplating process in our next chapter as well. Okay.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.